Students, in this example we are going to learn about how to test the variances of two samples. So did you remember in jet test we have learned how to test the means of two large samples as well as the means of two small samples. While checking the means of two large samples, we have used jet test. While checking the means of while testing the means of small samples, we have used t-test. But here in this model, we are going to test whether the variances between the samples are significant or not, and this can be done by another test called f-test. And its test statistic is calculated by s1 square, and first bigger variance is variance divided by smaller variance. Remember, formula is not always s1 square by s2 square. Sometimes it might be s2 square by s1 square. That means we have to take greater variance by smaller variance. So to explain this, I have taken an example. An intelligence test of two groups of boys and girls gives the following results and so on. It's talking about girls and boys. Girls mean is 84, standard deviation is 10, n1 is equal to 100. Similarly, boys, this is sample size, standard deviation and mean. Now the question is there any difference in the standard deviations? Either difference in the standard deviations are significant or not. We need to check this statement. So coming to the solution, we start with same procedure. We start with null hypothesis. So we take H naught as there is no significant differences between the variances, that is H naught is hyphens to s1 square is equal to s2 square. So this is the null hypothesis. Coming to second step, alternate hypothesis, bracket h1, we have to take there is significant opposite na, so there is significant differences between the variances. That means h1 is hyphens to s1 square is not equal to s2 square. That's it. This is second step. Coming to third step, that is level of significance. We call it as risk level. Let's take it is 5%. Coming to step 4, test statistic. So this is representing by f. But if you observe carefully, my standard deviations are given. Okay, so we need to take variances. So while writing the given data, so first sample and second sample. For the first sample was 100 and its standard deviation s1 is equal to 10. So we can say that s1 square variance is equal to 100. Similarly, for second sample, my n2 is equal to 80 and its standard deviation s2 is equal to 12 and its variance s2 square is equal to 144. So what I mean to say is our s2 square is more than to s1 square. So test statistic will become f is equal to s2 square divided by s1 square. So f is equal to 144 by s1 square is equal to 100. So that is equivalent to 1.44. So that's it. This is very simple one. Therefore f cal is equivalent to 1.44 and f tab at the rate of df1, degrees of freedom 1, is equal to first sample is what we call 100. So 100 minus 1, that is 99, and df2 is equivalent to 80. 80 means 80 minus 1, that is 79. And its f tab value is, and it is 1.35. So this is stable value and this is my calculated value. So now we can move with conclusion. So here f cal is less than to f tab. That means 1.44 is less than to 1.35. So this means our calculated value is more, na? So H naught is false and it may be rejected. It may be rejected. So we are rejecting the null hypothesis. This means our alternate hypothesis is true. So what is the alternate hypothesis we have taken? There is significant differences. Hence there is significant differences between the variances. That's it. This is the answer.